Hello and welcome to episode 15 of Cloud Tech 10 for the 19th of June 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Microsoft has joined the Cloud Foundry Foundation as a gold member. Integration with Azure has been around for a while, with new features being regularly added. For example, the Azure Cloud Shell has the Cloud Foundry CLI pre-installed. You can use Cloud Foundry with Azure's new Azure Database for MySQL or Azure Database for PostgreSQL, providing a fully managed database backend for your Cloud Foundry environment. Also, there's the Azure Cloud Provider interface. This provides integration between BOSH and Azure infrastructure components, such as virtual machines and virtual networks. The Azure Meta Service Broker makes it easy to provision and bind applications to Azure services, including Azure SQL Database, Service Bus, or Cosmos DB. And there's the Cloud Foundry plugin for Visual Studio Team Services, which provides support for continuous integration and continuous delivery for Cloud Foundry environments. Azure Functions consumption plans now have a preview of deployment slots available. If you've used Azure App Service, you should already be familiar with this feature. Deployment slots for Azure Functions allow you to manage multiple versions of an Azure function for staging of updated versions as part of the development lifecycle, making it easier to test new versions of functions before they go live and easily switch between production and test versions of a function. The deployment slots feature needs to be enabled before you can use it, which can be done from the Settings tab by clicking on under Slots. Once that's done, you'll now see slots available in your function app. In here, you can create a new slot. Let's call this one Staging. By default, enabling slots puts your function into read-only mode. So in order to create a new function, we need to turn that off. Next, let's create a standard HTTP triggered function as our production function application. Then let's go to the staging slot. As before, take it out of read-only mode and then create another HTTP triggered function. To help us differentiate between these, let's get the production function to return version 1 as part of its response, and let's modify our staging application and we'll get it to respond with version 2. So if I now test my production function, you can see that I get a response from version 1 of the function. As with deployment slots in Azure App Service, I can configure application settings to be slot-based settings, meaning that when the production and staging slots are swapped, the settings will either stay anchored to the slot or they'll move to the other slot with the application. We'll demonstrate this by creating a value, myStickyValue, which will be a slot-based setting, and non-sticky value, which will move with the application. Now let's perform a slot swap. I click the swap button here and then swap here to start the operation. Next, I need to configure the swap type. Swap will perform the swap now, whereas a swap with preview will only swap the configuration. We choose the source and target slots and we can see any warnings that the system has detected prior to the swap taking place. In this case, it's warning me about the application settings that I configured earlier and making sure I know that some of the values don't exist in all slots. I click OK and the swap begins. After a couple of minutes, the process has completed. If I now return to my production slot and run the same test again, you can see that it now returns version 2 in the response, meaning that our staging function is now running in production. Just to verify that, if we look at the staging slot, we can see it now contains the old version 1 production function. And if I check the application settings for the production slot, we can see that the slot-based setting of myStickyValue has remained with the production slot, whilst the non-sticky value setting is no longer here. If I check the settings for the staging slot, I'll see the non-sticky value has moved here along with the version 1 function app. The Video Indexer service was launched at Build 2017 earlier this year. This service takes videos that you upload, analyzes the content, and provides insights, transcripts, translations, and more. Let's upload a copy of the Build 2017 edition of Cloud Tech 10 to the Video Indexer website. I just click here to upload my first video. Then I simply drag and drop the video file onto the page. It takes a couple of minutes to upload the video, and then a few minutes more for the Video Indexer to complete its analysis. Once it's done, I click play and the video will begin to play back. You can see it's identified one person who appears in the video, so I'll let it know that person is me. Down here is a list of keywords that have been identified in the video. I think it's struggling a little bit with my accent, but you can see that it's identified a number of phrases, and if I click on those, it will take me straight to the point in the video where those phrases occur. If I click on transcript, I can see the Video Indexer has made a transcript of the video content. Again, it's being caught out by my accent a little, but on the whole, it's done a pretty decent job. I can also translate any of this into a different language. Back on the Cognitive Insights page, I can select a language. Let's go for French. Et voila! Now my keywords are translated into French, but also my entire transcript has been translated as well. Finally, I can click here to share or embed this video and the insights into another web page. Managed disks are now encrypted by default, thanks to the enabling of storage service encryption for managed disks. By default, all new managed disks, snapshots, and images will provide encryption at rest, with keys managed by Microsoft. New VPN gateways have been added, providing better performance, improved SLAs, and custom IPsec IKE policy selection. The basic VPN gateway remains the same with up to 100 megabits per second throughput. This VPN is best suited for non-production or development and test environments. The new VPN gateways, named VPN GW1, VPN GW2, and VPN GW3, come with a 99.95% SLA and support between 650 megabits per second and 1.25 gigabits per second throughput. VPN GW1 replaces the previous standard gateway, but provides provides performance 6.5 times that of its predecessor for the same price. VPN GW2 replaces the previous high-performance gateway with a performance increase of 5 times. VPN GW3 provides a new tier, offering up to 1.25 gigabits per second throughput. The new support for custom IPsec IKE policy selection allows you to set the exact cryptographic algorithms and key strengths for each site-to-site or VNet-to-VNet connection to comply with your enterprise security standards. The Azure VPN gateways provide a default set of cryptographic algorithms that work with a wide range of third-party VPN devices, but if that doesn't meet your needs, you can customize as required. Azure Traffic Manager has added fast failover and TCP probing features. With fast failover, the default interval for Traffic Manager to check the health of endpoints can now be set to 10 seconds, instead of the default of 30 seconds. You can also set the number of tolerated failures before an endpoint is marked as unhealthy to values between 0 and 9, and the timeout interval for each probe attempt to between 5 and 10 seconds. You can also set the time to live as low as 0. TCP probing is now available in addition to HTTP and HTTPS probing. This uses TCP responses to perform health checks and makes it possible to support endpoints that don't respond to HTTP-based health checks. This could be used, for example, to check the health of a database connection. The TCP probe typically has a lower overhead than an HTTP or HTTPS probe. Event Hubs now features an Auto Inflate option that allows you to scale up automatically to meet your requirements. Event Hub usage is measured in throughput units, which in turn reserves capacity. One throughput unit equates to 1 megabyte per second or 1000 events per second ingress, or 2 megabytes per second or 2000 events per second egress. Auto Inflate can be enabled when Event Hubs are created or configured on existing Event Hub instances. To enable the feature, just tick the Auto Inflate checkbox. Then you'll be able to specify the upper limit that you want to scale up to. The Event Hub instance will then be created with the amount of throughput units configured, but if usage exceeds this, Auto Inflate will automatically increase the number of throughput units until the upper limit is reached. Azure Analysis Services uses Azure Active Directory to control access to data models. Support for Azure AD B2B collaboration has recently been added, allowing you to invite users from outside your organization to access and work with your data models. Any valid email address can be used to invite a user. As an example, let's set up an external user to access an Azure Analysis Services model. Under Access Control, choose Add and then select a role. Here I'll provide the email address of the user that I want to invite. This user has a Microsoft account with an Outlook.com address, but any valid email address will work. That user will now receive an email invitation to join your organization, which they'll need to respond to. Whilst they're doing that, we need to give that user access to the model. So let's go to the SQL Server Management Studio and open our Analysis Services database, and then drill down to the Roles folder. We want to make our external user a member of the Internet Sales Administrator role that's already defined in this sample model, but we could easily create a new role if we wanted to. Under Properties, I choose Membership and then Add, and then I provide the email address of my external user. Now my external user has received the invite and joined my organization. So as the external user, I now open Power BI Desktop. I'm using Power BI in this example, but other tools such as SQL Server Management Studio or Excel could be used as well. I go to Get Data, then choose Azure and then Azure Analysis Services database. I'll provide the server name for the Analysis Services instance that I want to connect to, and then authenticate using the external account credentials that have been configured in Analysis Services. And that's it. I'm now connected to the model and can access and work with the data as needed. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe, and follow me on Twitter for more.